Hey, everybody. Today we're joined by one of our perennial favorites, Dr. David Carpenter. Dr. Carpenter is a public health physician who received his MD from Harvard Medical School. His earlier work focused on basic neurobiology and electrophysiological techniques. He pioneered the study of neurotoxicological impacts on IQ and altered behavior in children. He had a research position at the National Institute of Mental Health and the Armed Forces Radiobiology Research Institute in Bethesda. Afterward, he became director of the Wadsworth Center of Laboratories and Research in New York State Department of Health. And he played a major role in the creation of the School of Public Health, a partnership between the University of Albany and the New York State Department of Health. And he was the first dean. Dr. Carpenter's research is focused on the study of environmental causes of human disease, especially the chronic disease of older age, such as cardiovascular disease, hypertension, diabetes, arthritis, thyroid disease, and neurodegenerative diseases. He has studied the rates of hospitalization for these and other diseases in relation to living near hazardous waste sites, fossil fuel power plants, and other sources of contamination. I first met Dr. Carpenter back in the early 1980s when he was considered one of the world's authority on PCBs, and he played a critical role in helping us in that 30-year battle to get PCBs out of the Hudson River, polychlorinated biphenyls. And he is an expert also on endocrine disruptors, which PCBs are one. But I wanted you on today to talk about the disappearance of pollinators, and particularly bees, and the role of the neonicotinoid neonics, we call them pesticides, a class of pesticides that is now ubiquitous around the world, and that most scientists are now focusing on as the culprit in the disappearance of many, many pollinators. But we're seeing now these dramatic, I would say, global extinctions that are going on of bees and other pollinators. And I'm 69. I think you're a little bit older than me, right, David?
I'm a little bit older. I'm 86.
Oh my God, you're a lot older.
Well, my brain still works, I think.
Yeah, your brain works a lot. I would trade you. So, when we were kids, we saw bees, butterflies everywhere. And bumblebees were ubiquitous, and honeybees, everything. But now it's very, very rare now to see a bumblebee. And so tell us about what the science is, linking neonics to the disappearance of bees and to other pollinators, and what the impacts are globally.
Well, let me start by saying that when I was a kid and first driving, you'd drive your car along a road and you'd get smashed insects on your windshield all over the place. And that doesn't happen anymore. Why doesn't it happen anymore? It's because we have used pesticides so much that the number of insects in general, not just pollinators, but the number of insects general in our environment has gone way down. This has had enormous impacts on a whole variety of things. It's impacted the population of birds that we have because most birds eat insects, and there are fewer insects, and so there are fewer birds. Now, the specific incidents of the pollinators, which are a whole variety of species of bees, not just the honeybee that we all know or the bumblebee. I've had a personal experience with the bumblebee when I put my bare foot in a boot that had a bumblebee in the bottom, and they do sting and that hurts. But they play a very important role in our economy, especially in agriculture, because plants don't pollinate well unless they have insect vectors to transport the pollen from the male to the female sex hormones of the plants. And we're at a stage right now where in orchards and nut farms, there are so few bees left that people have to import colonies of bees to bring them to the fields at the time that the pollination has to occur, because the natural population is gone. All right, let's talk about the neonicotinoid pesticides, because This is the class of pesticides that's been most implicated in the decline of pollinators. Now, nicotine, which everybody thinks about being related to cigarettes, but nicotine is an agonist for the neurotransmitter acetylcholine. Acetylcholine is what's released from our nerves that triggers muscle contraction. If you're bitten by a cobra or another one of the neurotoxic poisonous snakes, they block our nicotine receptors and we die because we can no longer breathe or move. Now, the nicotinoid pesticides act on those same receptors. And the nicotinic receptors for acetylcholine, the neurotransmitter, exist throughout the animal species. They exist in honeybees, they exist in bumblebees, they exist in mosquitoes. All of the insects use acetylcholine as a transmitter. Neonicotinoid pesticides block that effect, and they, in fact, do it more potently than they act on the human nicotine receptor. So while the nicotinoid pesticides are not benign for humans, they're much more potent in preventing the effects of the neurotransmitter acetylcholine in insects. And there is a variation of the different species of insects and what the affinity of these nicotinoid pesticides is for their nicotine receptors. And it turns out that bees of all sorts are particularly vulnerable to nicotinoid pesticides. What appears to happen when bees are exposed is that their movements are disturbed, and particularly their ability to navigate back to where they came from. So they can't find their way back to their hives. And that results in their not being able to find the fields of apple blossoms or nut blossoms or whatever kind of blossom that they have such an important role in for fertilizing. And if the blossoms are not fertilized, if the pollen from the female is not gotten to the male organ, the fruit or the nut will not develop. So this is a major problem. Now, nicotinoid pesticides have been outlawed in many parts of the world, especially in Europe. The US always lags behind in regulation to protect both people and the environment and the ecosystem against pesticides. Neonicotinoid pesticides are widely used in agriculture, and the agricultural community, with the exception of the fruit and nut community, has been very resistant to restrictions on use of nicotinoids. I've been very involved in the attempt here in New York State to ban nicotinoid pesticides. We have not been successful yet. We almost were successful in the last state legislature, but not quite. So it is a risk versus benefit debate. There are benefits of pesticides to most kinds of agriculture. Many plants, corn particularly, does not depend on pollinators to get fertilization. Nicotinoid pesticides are used in corn, soybeans, a lot of the grain crops, and they're effective in killing the pests that would generate worms and whatnot in those crops. But the effect of these pesticides on our fruit and nut crops are absolutely devastating. And there has been a general lack of will in this country to consider those pollinators more important than the agricultural benefits of nicotinoid pesticides to the general agriculture.
Now, and I want to get to this whole notion of agency capture and why exactly EPA refuses to regulate this very dangerous and devastating pesticide. But I just want to talk a little bit about the action of the pesticide. Neonics act differently than other pesticides in that they act systemically. So rather than remaining on the surface of the plant, where the insect then would land and uptake them, they are absorbed by the plant and distributed throughout its entire system, to the seeds, to the leaves, to every, to the trunk, to the stem, to every part of that plant. And the amount of neonicotinoids in those, or neonics in the plant, is really, when it comes to flying insects, is extraordinarily toxic. There's enough in a single grain of corn. There's enough neonic to kill 80,000 bees. And, there may be impacts on human beings too that we're not seeing.
Well, you're absolutely right. And the fact that the neonicotinoids distribute to all parts of the plant is one of the reasons they're so effective against corn pests and soybean pests and so forth. But it's precisely the reason they're so deadly to the pollinators. And the problem is that agriculture is many, many different products. And if you simply only look at the cost of using a pesticide that selectively targets pollinators, you can't just consider the production of corn. And, now to talk about EPA, I have a number of friends at EPA, and I fight with EPA almost daily. EPA is a regulatory agency, and it has to balance the costs versus the benefits. It is very much beaten up by industry. It's beaten up by farmers, at least the farmers that grow corn and soybeans. And so it isn't that the scientists of EPA don't recognize the dangers of nicotinoid pesticides on pollinator crops, but it's that there is not the political will. Good scientists at EPA don't have authority to implement regulation. That's a political decision which balance the pressure of the industry versus the health effects. Now, EPA is not primarily a health agency. It's a regulatory agency. I will never forget discussions around contaminants in fish, where I found EPA to be on the good side because they were making advisories on rates of fish consumption based on the health effects. Whereas another agency, FDA, who had the authority to regulate the interstate commerce in fish, had actually been sued by the fishing industry in the Hudson River and prevented from making recommendations and standards for sale of fish cross state boundaries based only on health considerations. And the result was FDA had a standard for fish consumption based on the levels of PCBs, for example, that said, FDA allowed sale of fish contaminated to a level that EPA said don't ever eat any. Now, in this case, I would fault EPA strongly because they have not taken a position that allowed the federal government to regulate the sale and use of neonicotinoids at a level that would prevent the wholesale destruction of pollinator insects.
Yeah, well, when we sued EPA, or when we sued Monsanto, we were able to obtain discovery documents, which included Monsanto's secret correspondence with the head of the pesticide division at EPA, who was there for, I think, over a decade. His name was Jess Rowland. And although he was accepting a salary as a public official, public health official at EPA, he was secretly working for Monsanto, and he was killing studies for them of Roundup to make sure that the company's profit lines were protected when it was clear that Roundup was causing cancers in rats, causing cancers in mice, causing cancers in humans. He was doing everything he could to block any additional studies. And in fact, he was going to other agencies that were trying to study the links between Roundup and cancer and blocking studies there. In fact, he blocked one at ATSDR, which is another agency that looks at health effects of toxics in the environment. And they wanted to look at the links between Roundup and cancers. And he sent a note saying, I've blocked this, and you need to give me a medal for what I did to prevent them from doing a study that has scientific integrity. So you have actually people in you have scientists in the agency who are good scientists, who are doing real science. And then you have the people a lot of times who are running the individual branches of EPA, who are making sure that regulatory action never occurs. And that, has historically, the pesticide division has been one of the most corrupt divisions in the agency.
That's absolutely right. There's corruption at multiple levels. First of all, a lot of the industry funds research, and you can get any result you want from funded research. If you have conflicts of interest there, you can find something not to be toxic because you don't use high enough dose, you don't look at large enough animals, you don't follow them for a long enough period of time. So a lot of the industry funded research shows no adverse health effects. You have individuals within the regulatory agencies like EPA, they have conflicts of interest. And in many times, they got their positions at EPA because of pressure by the industry for EPA officials to hire them. I wrote a preface to a book. It was an interesting experience to review for many different chemicals, for PCBs, for Roundup, for electromagnetic fields, what a magnitude of conflicts of interest there are in people in the fields. It was interesting. I have a publication. Now, this is on a different subject, but it's on the magnetic fields from electricity. And I looked at publications since the year 2000. In 2000, there were 3 major meta-analyses showing that high magnetic fields increase risk of leukemia in children. And there are about 30 publications since 2000. About a third of them were published by academics, and they all showed a statistically significant increase in the risk of leukemia with exposure to magnetic fields. Another third were published by academics, and they showed an elevated risk, but it wasn't quite statistically significant. The other third was funded by the industry. Not a single one of those publications found any statistically significant association between magnetic field exposure and leukemia. So I think the lesson here is that conflicts of interest, whether you're a scientist employed by industry, employed by academics in universities, or whether you're a person employed in a federal agency, these conflicts of interest can make major determinations in what you report in terms of what the human health effects are. Now, that's not just true for human health effects, it's true for ecological health effects, as we have in the situation of exposure to neonicotinoids and health of pollinator insects.
Yeah, well, as you know, there's an axiom in our area of work, which is that statistics don't lie, but statisticians do.
That's right.
There's another one that says that statistics are like prisoners of war. You can torture them into saying anything you want them to say. And there's an entire industry of these mercenary biologists and mathematicians, et cetera. We call them biostitutes, who go to work for industry to generate, these kind of studies. And this was Monsanto actually launched this industry when it was defending DDT against Rachel Carson. And a lot of the blueprint that Monsanto at that time laid out was then later adopted by the tobacco industry, which was able to deploy these kind of scientists for 60 years. Ulysses Grant, the president of the United States, died of tongue cancer from smoking cigars. And back then, everybody knew that it had come from cigars. So that was in probably 1870, in the early 1870s. So 100 years later, in the 1970s, there was still arguments about whether or not cigarettes cause cancer because the cigarette industry, tobacco industry, had created these think tanks and filled them with stables of these kind of mercenary scientists who were generating all this phony science that exculpated tobacco from the cancer link. So even though this industry, everybody knew this industry was killing 1 out of every 4 or 5 of its customers who used its product as directed and had been doing it for at least 100 years. They were able to escape regulatory oversight for a century by twisting and torturing science to serve their purpose. And David, you and I have seen this across, we saw Monsanto do that with PCBs, and the General Electric Company and all of these other substances which are poisoning our children, that are causing these chronic disease epidemics, and that are exonerated, one after the other by prostitutes on the payroll of these crooked industries who are making billions of dollars from these products.
Yeah, so you don't have to just torture people to get them to lie. You can buy lies. And that's really what happens most of the time in our current society. You get a good salary if you work for an industry, but you're going to get fired if you don't toe the line. You can get supported for your research by an industry, but you're not going to continue to get support if you find results that don't agree with the bottom line of the industry. The other side is that it's very difficult to avoid any conflicts of interest. And I think most academics do that, but not all of them do, because there's a lot of industrial funding for research done in universities and colleges. And again, if you want to maintain funding, you'd better not provide a result that's contrary to the bottom line of the industry. And there are many examples of individuals that have been hounded by the industries because their research leads to results which are unfavorable to the product of the industry.
Well, David, I wanted to say that if I manage to get elected president, I'm going to bring you in as my scientific advisor, the way that my uncle brought Jerome Wisner in. And, we're going to get rid of these exposures, and we're going to get rid of particularly the exposures that are causing brain injuries in our children, that are causing chronic disease epidemics like diabetes, like obesity, juvenile diabetes, rheumatoid arthritis, all this retinue of autoimmune diseases that has disabled an entire generation of American children, of allergic diseases, peanut allergies and eczema, and all these neurodevelopmental diseases, including, the recent drops in IQ, all over the world. We've seen there's something, as you probably know, called the Flynn effect. And it shows that IQ has increased in every decade since 1900. And for the first time in the last couple of decades, we've seen drops in global IQ, I think, of as much as 6%, 6 points. It's not worth it. We need to eliminate these exposures. And I know it's not going to be politically popular, but I'm also going to restore the bug splatter on everybody's windshield if I get in there. That's probably not something.
These are the things
I votes for, but I'm going to do it.
These are the things I study, the things I care about, and I would love to work with you in any way I could.
Thank you, David. I'll talk to you soon. Thank you very much for joining us.
Take care. My pleasure.